Okay, welcome to Chapter 12, Part 3. Couple of things. Have you noticed that sometimes I say words really weird? I don't even know. Well, I'm from Arkansas, and I grew up with a Southern accent. And over the years, I've more or less lost the general Southern drawl, but there are like vowels that come out really weird. So that's what's going on with that. Just thought I would toss it out there. Okay. So this is Chapter 12, the last lecture. This should be a bit shorter. And we're going to, again, try to just explain things kind of straightforward and simply. Let's think about bone. Where did bone come from? Well, when you were in your embryonic form, essentially, you were mostly cartilage. So when we think about where you are now, or even where you were at birth, we need to think about what type of processes occurred so that the cartilage, in general, as part of the overall structure of your body, was then converted to bone. Now we know we still have cartilage, but cartilage is not the main type of material that's making up our skeletons. Now, there are animals like sharks and skates and rays. Their vertebral column is made up of cartilage. So that's what allows them to be buoyant and so flexible and, fierce and almighty. Okay. But for us, we need to think about how did we go from cartilage to bone? And then secondly, how do we grow? So let's take a look at some cells that are super important to this process. So bone growth and homeostasis. So cells involved in bone growth, remodeling. So that's when we break down the bone and release some of that calcium and phosphate and then regrow it. And then, of course, repair. So if you've had any injuries to your bones, my daughter has a good friend who just had an accident, got some broken arm bones. So, how do we heal? So we have our bone-forming cells. Cells. See, there we go. Osteoblasts. So a blast, building up. Okay? These are essentially bone-forming cells. And they are going to secrete that, it's called organic matrix, but it's mostly calcium and phosphate. And it is going to promote the storage of calcium in the form of calcium salt in that matrix of the bone. Okay, osteocyte. These are mature bone cells. So once you have cyte on your name, it means you're really thriving. So this is the mature bone cell. Just like a chondrocyte is a mature, you got it, cartilaginous or cartilage cell. Okay, so if you're a mature bone cell, then you're surrounded by all the things, and those cells are in the little lacuna, and they're hanging out. Osteoclasts. Now, when I think of class, I think breaking down, I think destruction. So catastrophe or chaos. So an osteoclast is a bone-absorbing cell. What the osteoclast is doing is breaking down our osteocytes so that we can release that calcium and phosphate into the blood. Now, we need calcium for muscle contraction. It's super, super important. We need phosphate. Oh yeah, ATP, adenosine triphosphate. There's a lot of important things we need phosphate for. So the osteoclast is going to break it down. It says bone absorbing, but essentially it's releasing these minerals into the blood. So every day you could be osteoclasting, then osteoblasting, and going back and forth. So our bones are just gently getting scrubbed and being released of minerals and then building up again. All right, pretty cool. So let's take a closer look then at the last thing on our study guide revolving intramembranous ossification and endochondral ossification. So ossification, so think osteocyte, os is referring to the bone. So ossification is the process of essentially bone formation. Now, we talked about, going back to your embryonic form, that essentially we were mostly cartilaginous, right? Until we needed, the proper time when we could start laying down our bones. So the way that we built our bone was both through intramembranous, okay? Intra sounds like it's within membranes, ossification, and endochondral ossification. So something to do with replacing cartilage. So let's take a look at the terms and what they relate to, and then we'll go through the process. Just slow it down and don't overthink it. Just don't overthink it. Okay. Intramembranous ossification forms the flat bones, so these bones of the skull. Okay, we didn't really go into a lot of different kinds of bones, but they are indeed flat and somewhat solid. Okay, so these are the bones that develop between sheets of fibrous connective tissue. Okay, so think about that. There were sheets of fibrous connective tissue, and then essentially those osteoblasts are going to come in. I don't care if you remember it's the periosteum, but essentially those osteoblasts in that layer of the bone, not the very outside layer, but near, that part of the compact bone, is going to carry out bone formation, ossification. Okay, so, intramembranous ossification occurs in flat bones. It is essentially developing between the sheets of some fibrous connective tissue that actually is kind of acting like the template, if you will. So we're just coming back and putting in the harder material. And the osteoblasts, of course, that's our bone building cells, are going to do that. Okay. Endochondral ossification forms in most of the bones of the body, because most of our bones are not like our flat bones, okay? So they are long bones. So all the bones of your arms and your legs, okay? So what's going to happen in this particular type of bone development is that calcified bone matrix is going to replace a cartilage type model. So instead of it being in sheets, it's essentially more in a three-dimensional kind of model. And then the bone is going to come in and essentially replace that cartilage. So this happens in long bones, and what tends to happen is that the bone is going to be replaced from the center of the bone to the ends. Okay, so there's a process of replacing that cartilage, or the cartilaginous model, from the center to the bones with bone. Okay, so also in this type of bone development, we have again that epiphyseal, or the growth plate. So again, as we were growing, we had the epiphyseal plate present in our long bones that was a band of cartilage, and essentially was there continuing to allow us to grow, our long bones to grow in length. Okay, so essentially it remains between what they call the primary ossification center and each secondary center, so it's going to allow you to keep growing. Once that has solidified or fused, or or the cartilage is now gone and it's replaced by bone, then you are not going to be able to grow any taller. So for me, I was like 13, I stopped growing. So 5'2.5". Okay, so the last bullet, cartilage is now present at two locations, the growth plate and what we call the articular cartilage, which covers the end bones, which you don't need to know that. But this figure is going to help us just kind of go, okay, what does this mean? So the reason why I left this figure here is just so you can kind of get an overview of what's happening with the endochondral ossification. I do not want you to know A, B, C, D, E. I'm not going to ask you to label something, but just going to pause for a minute and look at the changes that are occurring to get an idea of what's going on with essentially the chondrocytes. So what we're trying to do is replace the cartilaginous cells, and you see that as you move through here, and they gradually essentially get condensed into the growth plate, right? And the rest of this is getting replaced by bone. And as we move along, and especially during childhood, then we see that our bones look like the figure that we originally looked at. Okay? All right, that's the end of chapter 12. You guys hang in there. Reach out if you need me. Okay, bye.